In this video for S2 chemistry, what we're going to be looking at is how we get metals from rocks. And there are three ways in which we can get metals out of rocks. So metals are found inside rocks, either inside minerals, or as you can see in this rock, sometimes metals are just in the rock themselves. So we're going to have three parts within this video. In the first one, we're going to understand what we call an ore and give examples of ores and be able to describe how we can get some metals out of ores just by using heat and determine the reactivity of metals that are extracted by heat alone. So ores. Ores are naturally occurring rocks that contain metal elements or metal compounds. So an ore is a rock that contains metal elements or metal compounds. Examples of ores. Bauxite is an ore in which you can find aluminium compounds. Hematite is an ore in which you can find iron compounds. And you can see that the rock does not necessarily look anything like the metal. So bauxite is an orange colour, but aluminium is a silver metal. Hematite, however, does look a similar colour to iron. Then we have malachite, which is this green one, which contains copper compounds, and galena, which contains lead. Now, a metal plus another element is what gives us a metal ore. So for example, iron plus sulfur gives us iron sulfide. Zinc plus sulfur would give us zinc sulfide, and copper plus oxygen would give us copper oxide. But when we've got these rocks that either contain metals or metal compounds, how do we get the metal out of the rock? Well, it really depends on the type of ore and on how reactive the metal is and how stable the ore is. There are three ways in which it is possible to get a metal out of an ore, or extract the metal is the scientific word. Extract the metal from its ore. The first one, and this is for metals that are not very reactive, we can use heat alone. If the metals are a bit more reactive, we can use heat and add some carbon. And if the metal is very reactive, we need to use a process called electrolysis. So in the first part, we are going to be looking at how we can use heat alone. And as I said, heat alone is used for metals that are not very reactive. And the most common examples of metals that we can just use heat alone with are gold and silver. They are found uncombined in the Earth's crust, so they are not found as compounds, they are found as elements. And so sometimes you can just dig gold and silver out of the ground, and they can be separated by heat alone. So if you do have some silver or gold in a rock and you heat up the rock, what happens is that the gold or silver will melt and you can separate that from the rock. Metals that can be extracted just by heat are found at the very bottom of this list of metals called the reactivity series. So you can see platinum, gold, and silver are all at the bottom of this list, and they can be extracted from rocks just using heat alone. Now, what metals are more reactive? Well, remember when we looked at our periodic table in S1, we had lots of different groups. The group that was the most reactive in terms of metals and the group that was the least reactive. Can you remember? Well, the most reactive metals were group 1, called the alkali metals. The non-metals that are very reactive were group 7, the ones shown in green there, they're the halogens. And the group that was the least reactive is the red group called the noble gases. The group in the middle, the ones shown in yellow, those are our transition metals. And gold and silver and platinum are all found in that group. So that was looking at what an ore was. It's a rock that contains metal elements or compounds. And we saw how we can take platinum, silver, or gold, extract that from a rock using heat alone. Now we're going to move on to metals which we cannot just use heat, but we have to use carbon and heat. So metals that are a bit more reactive will be found as compounds inside rocks. And so they need a little bit more help to be extracted from ores. And the two metals that you can get out of rocks using heat and carbon are copper and iron. So copper and iron can be extracted from their ores using heat and carbon. And so this will be an experiment which probably will be done as a demonstration in class for you, where you will be extracting copper from copper ore, and you'll be using a Bunsen burner. So what you're going to do is you're going to add some copper ore with some carbon, heat it up, and you're going to have a plug of cotton wool sitting above. That's to stop anything reacting, and you heat it up a lot. You need to heat it up until it glows red hot, and the test tube might even start to bend because you're heating it up so much. Okay, so that's the cotton wool there, and that's your mixture of copper ore and carbon powder. Then what you do, and this is why it might be a demonstration, is while it's still really hot, you drop that test tube into a beaker of water, and that cracks the test tube and everything inside it breaks out into the water. And when you look at the bottom, that mixture that was copper ore and carbon, you should be able to see copper. And how you recognize copper is that it is a reddish orangey colored metal. So if you do that experiment in class, or if you get to see that experiment being done, you should hopefully see copper being formed at the bottom. And the copper needed the carbon and the heat in order for it to happen. Now, it's the metals in the middle of the reactivity series that can be extracted using carbon. So these ones here, we only really, the two that you need to know are iron and copper, but you can see that there are other ones in there that can be extracted using heat and carbon. Why is carbon needed to extract these metals? Well, in the ores, these metals are reacted with oxygen. So we would have copper oxide or iron oxide in the ore. When we add carbon to the ore and heat it up, the carbon steals that oxygen away from the metal and forms carbon dioxide. This displaces the metal, which just means it takes the oxygen away and the metal is left behind. For example, copper oxide plus carbon transforms to copper plus carbon dioxide. So it's what we call a displacement reaction. A displacement reaction is when if we have two elements bonded together and we add a new element, that new element steals one of the elements away from the original compound. So we have seen so far that there are some metals we just need to use heat to extract them from the ore. That was platinum, silver, and gold. Now we have just gone over that other metals need to be extracted using carbon and heat, and the two examples are copper and iron. The third process is that metals can be extracted from their ores using something called electrolysis. And this is only used for very reactive metals. Metals that are very reactive need to be bonded to something in order to be stable. So in metal ores, these reactive metals are very strongly bonded to other elements. If we want to separate that metal from the elements it's already bonded to, we need to use a lot of energy. And so some of these metals, such as aluminium and calcium, we have to use electricity to give a lot of energy to break that metal away from the other elements in the ore. And that process of using electricity is called electrolysis. If you remember from S1, we showed that electrolysis was needed to break apart a compound, and that's exactly what we are doing here. Alkali metals are also extracted using electrolysis. Remember, they are the most reactive ones, so they need the most electricity to separate. So things like lithium, sodium, and potassium. And this is what an electrolysis experiment looks like. Very reactive metals need lots of energy, and the way we can provide a lot of energy all at once is to use electrical energy and do electrolysis. And it's used to split a compound in solution. So electrolysis means splitting something using electricity. And we use a power supply, we use two electrodes, and we use a liquid form of our metal ore. So we either use an acid to dissolve it, or we have to heat it up to a very high temperature so that it melts. So extracting copper metal from its ore is the experiment you'll get to do. So copper we can also extract using electrolysis. And if we are doing that, the first step is to treat the ore with hydrochloric acid. That gets it to dissolve. And we call that type of reaction a neutralization reaction. Okay, you'll hopefully get to do this in class or see this as a demonstration. Once you've done that reaction, you need to filter it. Step 2 is filtration. So any bits of rock that were not the copper compound will be solid, and all of the copper that has reacted will form a solution. So we need to separate them using filtration, and when we filter, we will end up with a blue solution of copper chloride at the bottom, and it's that copper chloride that we are going to isolate or extract the copper from. And the third step is electrolysis. We're going to put the copper chloride solution we have made by dissolving the copper compound in acid and place two electrodes inside it. And what we find is that when we turn on the power supply, we will see copper solid forming on one side, and we'll see the distinctive copper orangey brown color, and on the other side we'll probably see bubbles of gas being produced. Now, electrolysis is only used for metals high up on the reactivity series. So those ones have to use electrolysis: potassium, sodium, calcium, magnesium, and aluminium. So how reactive are metals? We'll summarize. And we can summarize this by looking at how different metals are extracted from metal ores. The method used to extract a metal depends on its stability. And the more stable it is, the easier it is to remove. So metals high up in the reactivity series, you need to use electrolysis. metals in the middle, you need to heat them with carbon, and metals that are at the bottom, the least reactive, can be extracted just using heat. So we have gone over what a metal ore is, and we have looked at the three ways in which metals can be extracted. We've looked at how unreactive metals can be extracted just by heating them up. We've looked at how metals that are in the middle of the reactivity series can be extracted by heating and adding carbon. And then finally, for metals that are high up on the reactivity series, we need to use electrolysis. So that has been how metals are extracted from metal ores and rocks.